Okay, so another question from the 2012 paper. The circle shown in the diagram has as tangents the x-axis and the y-axis. That's the key statement there, because that means that the radius is the distance that the centre of the circle is from the x-axis and y-axis. So just if the y-axis is a tangent, then this distance here is the radius, and if the x-axis is a tangent, then that distance there is also the radius. Now, so we have to find the value of k. Now, if x plus y equals 2k, then I can say that k is on that line. X plus y equals 2k. Okay, so, and I can also say that the point 1, 1 is also on this line, because if I was to sub 1 in for x and 1 in for y, I would get 2. So I need to find out what the radius of this circle is for a start. Now, using Pythagoras' theorem here, now this distance here is r, and that distance is r. We need to work out this distance here though, if you can just see it. Now I'm just going to maybe draw this here, maybe a little bit bigger. So I've said that 1, 1 will be on that line, or on that circle. So that's the point where it's a tangent. So I need to find, so what's this distance here? Well, that's 1 and that's 1. So using Pythagoras' theorem, that distance there will be root 2. Now this is also the radius of the circle. So using Pythagoras' theorem now, I can say that r squared plus r squared equals r plus 1 squared. Now where am I getting that? Or sorry, r plus root 2 squared. So, hang on a sec just to correct that. Because this is the center of the circle from up there, you know, this will be the coordinates r, and I'm just focused on, so this is coming from, this version of Pythagoras' theorem is coming from this right angle triangle there. Now squaring that out, so r squared plus r squared, square the first, multiply the two of them and double it, so r times root r, and then double it, is 2 times root 2r plus 2. So 2r squared, take away r squared, so just form the quadratic. So if 2r squared, take this r squared across, take the 2 root 2r across, and take the 2 across. So that will give me a quadratic of r squared minus 2 root 2r minus 2 equals 0. Now, using Pythagoras' theorem, or sorry, using the minus b rule, you solve for r and you get root 2 plus 2, or you get root 2 minus 2. We're only interested though in the greater than 1 value. So root 2 plus 2 is the one that we'll take when you apply minus b to this. You'll get two answers, one of them positive, one of them negative. So this is the other negative one. So you could ignore this because we're only interested in positive values. So that's the value of r. And now from this, so as we've said here, if you look at this line up here, so the line that goes from there the whole way up, so at one end of the line I've got 1, 1. In the middle I've got r, and at the end I've got k. Now this is just a translation. The distance from this point to this point is exactly the same as the distance from this point to this point. Now the value of r, as we've worked out in the previous part, is root 2 plus 2. So this root 2 plus 2 is the centre of the circle. Now, what have I done to go from 1 to root 2 plus 2? Well, I've added on 1 plus root 2. Because if I add 1 plus root 2 to 1, I'll get 2 plus root 2. And likewise, to go from 1 to root 2 plus 2, I add another 1 plus root 2. So I do exactly the same to this. I add 1 plus root 2 to this. So this gives me then 3 plus 2 root 2 and 3 plus 2 root 2. So again, it just comes from the translation. How did 1 go to root 2 plus 2? See, this is the centre of the circle, and these are the two endpoints of the diameter. So this is the midpoint. So to go from 1 to root 2 plus 2, I must have added 1 and root 2. So 1 plus root 2 would give me root 2 plus 2. And then if I add this number again onto this, so 2 plus 1 is 3, and root 2 plus root 2 is 2 root 2. And I do the same for the y value. Okay.